let's continue working on our Polygon plane plugin. So I'm just going to load the plane which we had in the previous video where we saved it, and I'm just going to go back to edit plugin, and this is the unsaved version. So we saved it as a plugin, but this is the one where we had it just as an instance inside the scene. But if you choose so, you can also edit the actual plugin the same way. I'm just going to go back and delete some of these nodes which were just causing messiness in our scene and didn't really do anything. And what I want to do in this video is teach you how to group things together inside the lab, so you can reuse them over and over again inside the same graph or inside various different plugins. You can build up your own library of tools this way, which you can reuse inside all of your projects and save yourself some time and energy in the future. So if you recall, for our plane plugin, we had two major components that made it up. First was the vertices of the plane, and second was the polygons. And we had a vertex generator, which I opened up here. And along with the vertex generator, we also had a polygon generator, which generated the polygons. Both of these generators took some kind of an index. In the case of vertices, it was an index I, which went from 0 until the very last vertex. And using this index, it kind of generated the vertex based on it. To generate the actual vertex, we needed to figure out which row and which column of the polygon plane grid that vertex was located on, and using that X and Y or row and column position, we then created our actual vector. So what I want to do in this tutorial is kind of abstract away this notion of extracting the row and the column index based on some kind of passed-in index, because we do the same thing for polygons. For polygons, we used an index J as opposed to I, but we extracted our row and column using the same way. If you look here, we see that we see both of these operators. This one, VC, is responsible for the vertex index, for the column index, and VR is responsible for the row index. And both of these, they are then go in and participate in some other parts of the graph. But what we're interested in is basically taking these two nodes and grouping them together into one node, which we can then reuse inside the polygon operator. So to group these nodes together, you can just select a bunch of nodes like this using a lasso selection, and then you right click and select group. By doing so, we get a new node. It just assigned some kind of generic node name, but we get a new node which now takes all of the incoming connections for both of those nodes and produces outgoing connections for both of those nodes as well. So let's double click this node to get into it. And here we have our two vertex row and column indices, and they are the only ones that are present in this graph. Both of these nodes share similar connections. The value 1 for our row index was the same as value 1 for a column index, which was the index I. So we can reuse this value. So let's connect this index I into our value 1 so we can share them between these two nodes. And let's just remove the empty output which we have left behind. So let's just remove it. Now we only have 3 inputs left, and the second value for both of these was the vertex count per column. So we can also share these between these two nodes. So I'm just gonna drag that input in there and remove the one that we have left over. So I'm just gonna right click and remove it. So what we're left here is two inputs that we really need for this graph. The first one was index, so let's just call it index. And the second one, let's call it count, because it actually takes some kind of count, in this case count of vertices per column, and then it deduces the X and Y coordinates from that count. And the output, so this was the row index and this was the column index. So let's call this output Y, because row we count as vertical index, so it's going to be Y, and this is going to be output X. Actually, let me stick with lowercase values here, lowercase names here. If we go back out of this graph now, we can see that it is much simpler. We have output X and Y from this graph, which specifies the row and column index, and we have an index and account input, which is now a nice, neat-looking graph, and it kind of self-explains what it takes in and what it puts out. Let's rename this to something different, like get 2D coordinate. Because essentially what this node does is it takes an index and produces a 2D x and y coordinate. So now we have this node, but right now it is an instance within the graph, because as you can see, it is located under vertex generator, and it is like its own node. We don't have any meta XPath attached to it, which means it only exists in that one specific location. What we want to do is we want to save it as a meta node. Just like we saved our plugin as a meta node before, we want to save this particular graph as a meta node. It's not going to be recognized as a plugin, but we will be able to reuse it inside the graph. So I'm going to start typing in values here, and the category which I will save it in is going to be Ephere, and then the subcategory is going to be operators. And I find that generally it is a good idea to follow this kind of convention. The first part of your category would be the name of a company, or maybe your first or last name, just to separate yourself from other people's tools, which you can also have present in your library. And the second one is just denoting what kind of tool this is. And in this case, this is an operator, or actually let's call it utilities, because it is a utility tool which helps us to do things, but which can be reused in many different types of graphs. Again, it's red because we don't really have the last name yet, and the last name of this tool is going to be the last part, sorry, of this tool is going to be get 2D index. And now that we have typed these values in, we have our save button. So we can, if we just save this right now, it's going to save this, but inside our previous graph, it's still going to leave our node as an instance node. So if you click back onto it, it's not going to get this node, but it's just going to go back to our get 2D coordinate node. But then we also have a drop-down button here. If you click this drop-down button, you can see that it says save and replace. And essentially what this will do is it will save this graph as a meta node. And then whatever instance of this node we had in the previous graph, whatever instance we're currently editing over here, it's going to replace it with an instance of that meta node. So let's see what happens if we press this button. So it gets resaved. Now, as you can see, this is a whole new graph. So this graph is actually its own meta node. We have the meta node XPath here. And as you can see, the instance XPath is not really pointing to anything because this is the top root level of this meta node. If we click back twice, actually, we go back to this get 2D coordinate graph. It no longer has that icon, the graph icon, which means that it is actually a meta node. And this is an instance of that meta node. If I double click on it, again, you can see that we go back to the meta node as opposed to that instance node. So let me get out back into our root of the plugin, the root graph of the plugin, and let's jump back into the poly generator this time. And with poly generator, we had FR and FC as opposed to having VAR and VC. So these two calculate the face column and face index. But if you look at the pattern, it is pretty much exactly the same pattern as we had for vertices. So it takes some index j, and it takes the number of faces per column, and it gives us the face horizontal and vertical face index. So if we right click right now and we start typing our the XPath that we saved our plugin as, but instead of forward slashes, here we use dots. So it's Ephere utilities get 2D index. And there you go. This is exactly the node, the meta node that we have just saved. If I click on it to create, you can see that it creates an instance of that same graph which we just saved. It doesn't really have any default values assigned. It's probably a good idea to go back and assign a default value to index. So it probably could be something like 0, and count could be at least, it has to be 1 or 2. And we covered how to do this in the previous video, but for now it's not really that important for the point of this video. So let's wire the value j into the index, and let's wire the value m into our count, and replace the coordinate. So fr is the row index, so it was our y coordinate. So we'll take this y coordinate and we'll put it whatever fr was. And fc was our x coordinate, so we'll take the x coordinate and put whatever fc was wired into. So it was wired into here. And now we have completely replaced these two nodes. As you can see, their outputs are not pointing to anything, so we can just cleanly remove them without losing any functionality. And we have replaced our functionality with this utility node now. So I can go back and continue just like before. So we didn't lose any functionality. We just kind of grouped these nodes together, and we reused the nodes inside a graph, which is now reused inside multiple other graphs. So if I click here again, you can see that it goes back to our get to the index to the index utility. So you can do this with much more complex graphs. Obviously, this was just a simple example, but it just shows you how once you have established that you have something useful, you can kind of group it together, create a meta node from it, assign it some useful XPath, and then you can save it out and reuse it in all future graphs. And just to on the last note for this video, I'm going to go to our library and go to our templates. And as you can see, this is what we have just created. So see you in the next video.